Welcome to The Explainer. Today we're going to pull back the curtain on two, super simple ideas that secretly organize pretty much your entire digital world. I mean, they're so basic, but you're using them constantly, every single day, without even thinking about it. So let's kick things off with something you do all the time. You're on the web, right? You click a link, then another and another. Then you hit that back button, and poof, it just works. It knows exactly where you were before. How? How does it remember that path? Well, it's not magic, not at all. It's actually a really clever and really specific rule for just keeping track of stuff. And believe it or not, the answer starts with something you'd find in just about any cafeteria. Yep, a simple pile of plates. I mean, think about it, right? When a clean plate comes out, where does it go? On top of the pile. And when you need one, which one do you grab? The top one, of course. It's the easiest. Well, that simple, totally intuitive action, that's the whole idea behind what's called a stack in the computer world. Yep, that's literally what it's called, a stack. It's basically an ordered list, but with one super strict rule. Everything, and I mean everything, happens at the top. You add things to the top, you take things away from the top. That's it. And as you're about to see, that simple order, it's the key to everything. So what this creates is the one fundamental rule for any stack. The last plate you put on the pile is going to be the first one somebody takes. The last thing in is the first thing out. And there's a cool little acronym for this, LIFO, last in, first out. Okay, so there's some lingo here, but it's easy. When you add a new item to the top of the stack, putting that clean plate on the pile, that's called a push. And it's a really logical two-step thing. First, the computer just checks, hey, is there even any room here? Because you can't just keep piling plates on forever, right? If there is space, then boom, the new thing gets placed right on top. Simple as that. All right, so what about taking something off? Well, that's called a pop. You're just popping the top item right off the stack. And just like before, there's a quick safety check. The system asks, is there actually anything here to take? You can't grab a plate if the pile's empty, right? Makes sense. If there is something there, then the top item gets removed. Easy. So here's the really crucial part. This whole last in, first out thing, this LIFO rule, it's absolutely perfect for any time you need to undo something or backtrack step by step. And boom, there it is. That is the so-called magic behind your browser's back button. Every single time you go to a new page, its address gets pushed onto a stack. When you hit back, what does the browser do? It just pops the last website you visited off the stack and takes you there. It's the exact same idea behind the undo button in a text editor. Every change you make gets pushed, and undo just pops them off one by one. Okay, so that's a stack. Pretty cool, right? But what if the rule wasn't last in, first out? What if you needed a system that was, a bit more fair? So let's switch analogies for a second. Let's see how a different rule creates a whole different kind of order. Forget the pile of plates. Instead, picture a line, a queue for concert tickets. The rule here is totally different, isn't it? The first person to get in that line is the first person who gets served. And just like that, you've pretty much described a queue. In the computer world, it's an ordered list, just like a stack, but it has two ends that matter. You get in at the rear of the line, and you get served from the front. Makes perfect sense. And this gives us our second big principle. It's called FIFO, or first in, first out. It's really the core idea of fairness when it comes to processing things. The first thing that comes in is the first thing that goes out. And just like stacks, queues have their own special lingo. Instead of push and pop, when you get in the back of the line, you NQ. And when it's your turn at the front, you DQ. A little different, but the same basic idea. So where does this kind of first come, first serve system actually show up? Where is it super useful in our digital world? Well, a perfect example is your printer. Think about it. When you send a bunch of documents to print, the computer doesn't use a stack. Can you imagine the chaos? The last thing you printed would come out first. No way. Instead, it uses a queue. It lines up all your print jobs, making absolutely sure that the first document you sent is the first one that actually comes out of the printer. All right, so let's just recap real quick. We've got the stack, that's last in, first out, our pile of plates. Then we've got the queue. First in, first out, our orderly line of people. Two totally opposite rules, right? But both are incredibly powerful ways to manage how things get done. Okay, so why does any of this actually matter to you? I mean, beyond being a neat bit of trivia, why should you even care about stacks and queues? Well, it's because this stuff isn't just some abstract theory for computer programmers. These are like the invisible traffic cops of your digital life. They take the absolute chaos of all that information flying around and they create a predictable, logical order that we totally depend on every single second. And you know what's really amazing? It all just boils down to two core ideas. Just two simple rules for getting organized. Last in, first out, and first in, first out. That's it. And those two principles are enough to power countless applications that you and I use every single day. Once you get these basic ideas, you start to see the hidden logic everywhere. You see the structure that makes our complex digital world even possible. And it really makes you wonder, doesn't it? What other simple, elegant rules like these are hiding just beneath the surface, making everything tick?